Good evening, class. This is a continuation of our second week lectures and on EGR 3430, and I'm going to cover the final half of Chapter 4. So we'll start on page 149 with independence, conditional probability, and the multiplication rule, section 4.6. And we've already talked about independence and dependent variables, so this is kind of to reinforce that and give a different approach on how to test for that. So that's kind of the goal here. Two events A and B are said to be independent if and only if the probability of event B is not influenced or changed by the occurrence of event A, or vice versa. And so they walk through some examples there of color blindness. Tossing die is a real good one. It's pretty clear as an example. Rolling a single dot on the die is mutually exclusive from getting a 2, or if it's a 6-sided die, then you get each one of those potential outcomes is its own independent event. So that gives you that probability of a given independent event on a die is 1 out of 6. So it kind of goes through there. The general multiplication rule of probability is the probability that both A and B occur when the experiment is performed is the probability of A intersect B, that upside down U means intercept, and that is equal to the probability of A times the probability of B, and then with the line there, you say given A. So that's how that's denoted, and so that equation can be used as the general multiplication rule. So it walks through the example there of visualizing an experiment using a tree diagram for a red toy and a green toy, and you can kind of see the simple events that come out there, and we can say the event that both toys are red. So the probability of B is the first choice intersect, or R on this first choice intersect R on the second choice. So you get down to the bottom equation there, probability of A equals probability of R on the first choice can happen twice, and then that gets removed, and then the probability that R is on the second choice given R on the first. So that's how that given works, and that's 1 out of 7. So that equation, or that result on the bottom of page 150 shows you the solution to that question there. So conditional probabilities of event A given event B is at the top of page 151. Gives you that equation there. Again, this is really pretty basic, simple stuff, so for me to explain it in too great a detail doesn't make much sense unless we want to work one-on-one on that. So if you're having difficulty with some of the problems set up in that, but in general, it's pretty much read through it, get a good clear understanding of it, practice some problems with it, and then be kind of prepared to memorize it. So that's really all you need to do on these conditional probabilities. And some of the problems are pretty interesting, so hopefully the ones that I assigned will give you some enthusiasm. Okay, if you go to page 152, it gives you how to check for independence. Two events A and B are said to be independent if and only if either P of A intersect B equals P of A times P of B. So, or you can go P of B given A equals P of B. And then otherwise, the events are said to be dependent. So there's a mathematical way to check for independence. So with that, I did assign, oh, I haven't assigned any questions there yet. I'll do that. I want to go ahead and skip over to page 163. We're going to skip the Bayes theorem for now. It's an optional section. Discrete random variables and their probability distribution. So this is kind of a, I think we kind of talked at the beginning that we've covered a lot of variables and what data exists and that sort of thing. But what's a random variable is a little bit of a qualification to a variable in that it's this phenomena that exists in nature. It's maybe a parameter like temperature or pressure, barometric pressure. Maybe it's a voltage in a circuit, and you can test it several times using an instrument, a barometer, thermometer, voltage meter, and you'll get a lot of different readings across within a certain range, right? So those readings are, since they kind of bounce around, those are random in nature when that's happening. And like I mentioned before, if you're expecting a random behavior and then all of a sudden you see some patterns happening that aren't so random, then that's a special cause. So that's how statistics is useful for problem solving. So that's why trend data is real helpful to get the data. They call it voice of the process, to evaluate and look for trends in that data. So variable X is a random variable if the value that it assumes corresponding to the outcome of an experiment is a chance or random event. So you can think of many examples of random variables. X equals the number of defects on a randomly selected piece of furniture. X equals a SAT score for a random selected college applicant. So again, we've got the population, and then we're going to randomly select with samples and items and unique sample pieces out of that population, and then that'll give us it'll give us data about the random variable. So then we get into the probability distributions. So this is, again, we're taking this is one of those stair steps that once you take this step into the relative frequency distribution, that we're going to start into this conversation almost full time about distributions and how the distributions behave. So we're going to go from a real elementary level, and this is a real cardinal crux hinge point where we're going to take that basic knowledge and now we're going to put it into the relative frequency distribution and come up with probability distributions. So the probability distribution, looking at the definition on page 164, the probability distribution for a discrete random variable is a formula, table, or graph that gives the possible values of X and the probability P of X associated with each value of X. So if you look over at page 165, there's a probability histogram. So across the horizontal axis are the values of X, and then there's the probability of each value of X. So that's a real discrete probability distribution, because if the value is 0, you got a 1/4 chance. If the value is 1, you've got a half chance, and then you got a quarter chance again for the value 2. So one of the requirements for the discrete probability distribution is the probability of all of the values has to has to total 1. So I guess that's the second bullet there. The sum of P of X equals 1. But then each value of the probability of each value, lies between 0 and 1. So that's kind of the nature of that. So that's pretty intuitive. But, you'll actually use that as a means to solve some of the problems, because if you've got 3 different items and you know the probabilities of 2, then you know that they all equal 1, so you can solve for the third probability. So simple math, but you got to rely on this requirement, nature of the discrete probability distribution, in order to solve that problem. So you got to know that that tool is available. So then we get into the mean and standard deviation for a discrete random variable. So notice, just kind of, it's implied there, but we're talking about population parameters of mean and standard deviation. So, and keep that in mind, because we could use a simple, they talk about the expected value of X. I don't think I'll be asking any questions about expected values. We'll just be working on means and standard deviations. But they do have a definition there of, on page 167, of the variance. So, and then a definition of the standard deviation, sigma, of a random variable X is equal to the positive square root of its variance. So, again, pretty basic statistics there. But the key point is population, and we're drawing random sample pieces from that population. So if we're not drawing randomized sample pieces, then we may not be able to say we've got we're not really looking at a randomized system that would fall under these rules for the discrete random variable. So I think there's a little bit of exercise there for you to see how to do this in my Minitab, and I'll try to find a few more questions that we can look at in this last half of chapter 4, and we'll catch up with you guys later. Thank you very much. Have a good evening.